We've got mean orbit in r meters, period, revolution t seconds. Things I've got to show that this value has approximately the same value for each value. That's okay. Let's do Mercury first. R cubed, so I've got to do 5.8 times 10 to the power of 10 cubed times t to the minus 2, so that is 1 over t squared, so it's 1 over t squared, which is 7.6 times 10 to the power of 6 squared. And what's that equal? Well, call that 6. That's 6 cubed is 216 times, and that'll be 10 to the power of 30 all over, call that 8. 8 squared is 64 times 10 to the power of 12. That equals, let's do 216 divided by 64. Well, it's about 3, isn't it? 180, 190, let's call it 3, very approximately. So it's 3 times, and I've got power divided by power, so subtract them, 10 to the 18. I'll do for the first one. B, Jupiter, is 7.8 times 10 to 11 cubed times 1 over, and then t squared, so 3.7 times 10 to the 8 squared, and that equals, call that 8. 8 cubed is 512 times 10 to the 33 all over, call that 4 squared, 16 times 10 to the 2 8 16, and this approximately equals, well, 3 16s are 48, so if I made it 30, approximately equals 30 times by 10 to the subtractions here, that'll be 17, which does equal 3 times 10 to the 18, as I had before. And then finally Pluto, approximately equals 5.9, call that 6 cubed, that's 216 times by 10 to the 36 all over, I've got a square 7.8, so call it 864 times square 10 to 9, which is 10 to the 18, and that equals, well, I've had this 216 divided by 64, exactly the same thing again before, so it's about 3 times, and that's 10, 36 take away 18 is 18, so they're all roughly the same. And the Earth takes 1 year for one orbit of the Sun. Yeah, excellent. Find the mean radius of the Earth's orbit. So we're trying to find what r is, and to do that I need to find out what t is. So t equals the seconds for 1 year. So there's 365 days in a year. Each day's got 24 hours, and each hour's got 3,600 seconds. And that's equals about 3 times 10 to the power 7, roughly. So now we can do it. We want to work out we know that r cubed t to the minus 2, that must equal the same values I've got for all the others, which is 3 times 10 to the 18, and so that means r cubed over 3 times 10 to the 7 squared, that's the t to the minus 2, equals 3 times 10 to the 18, and that means that r cubed equals 3 times 10 to the 18 times by this bit, 3 squared is 9 times 10 to the 14. So r cubed equals 27 times 10 to the 32. And so I've got to cube root that. And unfortunately, I can't divide that by 3. So I got to add 3 times that. But r equals 1.4 times 10 to the 11 using my calculator. That's not what it says at the back, and that's because it takes more accuracy. And I did these in my head. If you use them on a calculator, so the calculator, this one gives you 3.3779 times 10 to the 18. This one gives 3.46641 times 10 to the 18. And Pluto gives 3.37572 times 10 to the 18. So all of them are roughly 3.4 times 10 to the 18. And if you do the same thing, I can squeeze it in here. This bit here also works out to be 3.1536 times 10 to the 7. And if you do that and get r cubed over t squared, which is 3.1536 times 10 to the power 7 squared, and if you put that equals to 3.4 times 10 to the power of 18, because that's what all the numbers roughly equals, that does give you that r equals eventually 1.5156 times 10 to the power of 11, and then that comes to 1.5 times 10 to the 11. It's difficult to know how accurate to do it. I certainly couldn't be getting that in my head. That's done.